Can you please confirm if I'm audible? Am I audible, guys? Please type in the chat box or open your mic and tell if I'm audible. Can you hear me? Hello. Can someone confirm if I'm audible? Hello. Okay, fine. So let's start this week's session, that is week 4. I'm Anand Singhal, a PhD student from IIT Jodhpur, and I'll be assisting you in solving a similar assignment problem from week 4 for the course Digital Electronic Circuits, which is taught by Professor Gautam Saab from IIT Kharagpur. As we already know that in the previous weeks, in the past 3 weeks, we have covered some of the basic implementation of certain gates such as universal gates, NAND NOR gates, and we've also talked about some of the basic diodes and transistors, that is the device part. And in the last lecture, we generally covered the part of K maps, etc., and some of the hazards that can be covered in the circuit aspect. So in this week, we will be covering some of the more combination circuit, that is multiplexer, demultiplexer, etc. There are several circuits which can be used itself to make some gates or some basic some expressions. So we'll be covering basically most of the multiplexer, demultiplexer, encoder, etc. in this particular lecture, and subsequently we'll be covering some of the more combinational part till week 6, and then we'll move ahead to the sequential part from week 7. So I guess I gave you some problem in the last week, so do you want me to cover that problem also? Has anyone done that? I've given you certain problem, I guess, to make some expression using only NOR gates. Should I cover that, or should I straight away start from this particular topic? Please suggest. You can type in the chat box. I guess the problems were something like w plus x bar y plus z using NAND, and similarly I guess it was w plus x using NAND, two input NAND. So has anyone done that, or should I skip this and start with this lecture only? Anyone with the answer? Please at least let me know if I can skip or I should solve these problems. Okay, since I'm getting no response, so I'll be skipping these problems then. Okay, so fine. So for this doubt that you asked, if the total cost problem, I guess it is in the week 3 assignment, right? Okay, so remind me again. So I'll be covering this particular problem. Maybe you can mail me this particular problem. I will also cover it in the next lecture since I don't have access to the assignments right now. So I'll be solving this particular problem, whatever you're asking. So you can just let me know uh, what is what exactly the question number is, and I'll be covering that in the next lecture for this particular problem that you are asking. For now, we'll start with the multiplexer itself. So let's start. So I'll be basically telling you some of the basic that how what is a multiplexer and what is the use of a multiplexer. So this question covers some of the basic concepts or theoretical part of the multiplexer, and after that we'll be solving some of the numerical or some of the conceptual problems that are related to circuits in the multiplexer. So in this particular question, it has asked that which of the following statements are true. So you can also write your answers in the chat box if you already know, and I'll be solving it simultaneously. So the statement says that multiplexer, the first statement is selects one of the several inputs and transmit into a single output. So yes, so a multiplexer is basically n cross 1 circuit, that is it can have several inputs, that is multiple inputs, and it only have a single output. And it has certain select lines which are there. So I'll be explaining you what is this. So multiplexer is also known as many to one switch. You might already been taught in this in the theoretical lectures, and it is also known as a selection switch. We have certain inputs, let's say this is I0, I1, something like I3, and it is somehow connected to the input using a single output. So if I talk about the option A, so it has several inputs and it transmitted to a single output. So option A is correct, option 1 is correct basically, and option 2 cannot be correct because it is just opposite of that. And then it says it converts parallel data into serial data. So yes, you can see there are several data streams which are converted to a single data stream. So this is also true that it converts parallel into serial data, and it is a combination circuit because it does not have any latch or clock. So statement 1, 3 and 4 are correct. So option C will be the correct answer to this. So let me try to explain you the basic circuitry behind it. So I'll be taking maybe a 4 cross 1 to for a simple understanding of you. So for a 4 cross 1 mux, we have two select lines. We have four inputs. That is I0, I1, I2 and I3. And we have a single output. Let's say that is F. So what happens basically in the mux is it uses this select lines. There can be four possible combination. Yeah, so there can be four possible combination. For the combination of 0 0, it will select I0, I1, I2 and I3 similarly. So this is how it works. Yeah, and so let me try to make the circuit of this particular mux, how it is exactly working. So we have several AND gates, that is for the select lines I'm making. So this bubble basically means the inverter part. So if I make a S1, now what happens is this is connected to, so there are four inputs in a multiplexer as I have shown in the previous slide. So these four inputs are basically I0, I1, I2 and I3, and on the basis of these select lines, we just convert these I1, I2, I3, I3, and it has a single output as already said, which is connected by OR gate. So this is basically a circuit of a multiplexer. And if I do the calculations now, that is let's say this S0 I'm just making it short, so I'm writing them as m naught, m1, m2, m3. So basically this f will be m naught I naught plus m1 I1 plus m2 I2 plus m3 I3. So this is how a multiplexer basically works inside a circuitry. It has several AND gates and a OR gate for the final implementation of it. So let's start with a certain example, maybe. Okay, how do we implement functions? So let's say I'll give you function implementation using mux. So let's start with a basic mux only, that is a 4 cross 1 mux. Let's say it has two select lines such as p, q, and it has certain outputs, let's say in terms of variable, that is r, maybe r, randomly I have written them. And I now have a function of pqr as an output. So we need to compute this particular function, that is pqr. Sorry, that is f in the form of pqr. So as I have told you already, how does it work? It has four select lines. So basically what will happen is, for the first part it will be 0 0, that is p bar q bar. For the second part it will be p bar q, that is 0 1, then p q bar, that is 1 0, and for last it will be pq. So similarly, so this is was m1 m not m1 m2 m3 in the previous circuit. So we can write them directly. So what I'll write is p bar q bar is getting multiplied by r, then p bar q is getting multiplied by 0, then p q bar is getting multiplied by r, and finally I have a pq which is getting multiplied by 1. So for this particular circuit, the final f will be something like this. So this is will get 0. So this is how a multiplexer works, and this is how it works on the basis of select lines. So is there any doubt in this particular circuit? Please type in the chat box if you have any doubt, or if you fine. So let's move ahead for the some of the basic concepts. So now the question says that how many 2 cross 1 multiplexers are required to generate 2 raised per n multiplexer. So it is a very popular, very easy question in the gate exam also, that they generally give you a higher order mux, let's say a 5 1 2 cross 1 mux, and they ask you that how many 4 cross 1 mux are required to make this particular mux. So in general, it is giving you some of the notation that we have been given with 2 cross 1 mux, and we want, let's say, 2 raised per n mux. So how many particular multiplexers will be required? So we need to calculate them. So to get an idea, let's say let's start with a simple example, that we have a 2 cross 1 mux and we want to make a 4 cross 1 mux. Okay, so let's say we have 2 cross 1 mux. So I can write this as 2 raised per n, 2 raised per n cross 1. So here n will be 1, here n will be 2. So what I'll do is, the basic shortcut to that is, you will have to see the inputs whatever is given in the question part, and you will just continue to divide till you get the remainder as 1. So what I'm trying to say basically is, for a 2 cross 1 and a 4 cross 1 case, what you will do is, you will divide this 4 with 2 to have got a 2. So whatever number you will get, you will again divide it by the minimum number, and then you have got a 1. So this is the final number, and you need to add all these, basically all the answers that you have got to get the final answer. Something like, so for a 4 cross 1 you will be getting 2 plus 1, that is 3 marks. Is there any doubt in this particular thing? Please ask if there is any doubt, or let me know. Okay, fine. So if you don't have any doubt, so let's say now I have 2 cross 1 and 8 cross 1 marks. So similarly I'll go ahead doing the same thing. So you will see, you will get a 7 marks out of here. So in general, if I take 2 and here I take 2 raised per n, so what will happen is, you will be getting 2 raised per n, that is Let's say for a case of n equals to 2, you were getting, I guess, 3. Yeah, 3. For a case of n equals to 3, you are getting 7. So this is 2 raised to power 3, that is 8, minus 1 will be 7. Similarly, 2 raised to power 2, 4 minus 1 will be 7. So if I try to write it in the form of generic terms, so for 2 cross 1 mux required to generate 2 raised to power n mux, we will require 2 raised to power n minus 1 muxes. So the particular question, yeah, so answer will be option B. Any doubts in this? I'm just making you familiarize with the basic terms and how can we convert them. So is there any doubt? Fine. So if you understood this concept, so let's try this question. Maybe you can take 2 minutes and quickly let me know the answer. So this is very easy. You have been given certain 8 cross 1 or 2 cross 1 muxes, and you need to construct a 16 cross 1 mux out of it. So maybe you can try to draw and let me know what will be how you are getting this answer. You can take 2 minutes and let me know if you have done it. So just to clarify, it has already have a 16 cross 1 mux, and you have been given 8 cross 1. So we'll start with that and we'll see if we need a 2 cross 1 mux. So I'm doing the same thing again. So now I have a 16 by 8, that is a remainder is 2. Now since the minimum is 8, so we cannot divide it by 8. So what we will have is, since we have left with a remainder of 2, so we require a 2 cross 1 mux extra. So we will be requiring 2 8 cross 1 mux and 1 2 cross 1 mux, that is also given in the question. Let me make it easier. So since for a 16 cross 1 mux, if I try to make, so we will be requiring 16 inputs, right? We will be requiring 4 select lines and we will have a single output. So if I make 2 8 cross 1 muxes, it will give me 8 outputs, that is from I0 to I7, let's say. This will give me from I8 to I15. This has 2 select line, this has 2 select lines, so the total inputs will be now 16. This will have a single output, this will have a single output. So if I use a 2 cross 1 mux now, because since I have 2 inputs, so it will give me that f that is required. So I have made a 16 cross 1 mux using 2 8 cross 1 mux and 1 2 cross 1 mux. Is there any doubt? So let's try certain questions now for from mux only. So let's say I give you a problem. I have taken a 2 cross 1 mux in which I have a select line A, I have a input B and a complement of that as one of the other input. I have a F. So this is a 2 cross 1 mux basically. You need to calculate this F. So let me know this quickly. What is the F that you are getting? You can type in the chat box. Okay. So someone commented X NOR gate. So let's say this will be A complement, this will be A. So final F will be A complement, B complement. That is, I'm getting B complement from here. It is this, and here it will be B plus AB. So yes, this will be a XNOR gate. So some of the people like say that mux is also a universal gate because you can make any uh, particular expression out of this mux. So mux is can also get act as a universal gate. It is a particular circuit which you can use in a certain way to get any particular gate. So similarly, can anyone tell me if I tried to make let's say a OR gate using the similar terminology, I can use one select line, that is one function here and two function here. So what will be this? Let's say I'm naming this as P, Q and R. So what will be this P, Q and R in terms of A and B, so that I will get a let's say OR gate. Can someone tell quickly? You can take 1 or 2 minutes. Any suggestions? So if I again use this let's say as a one of the input, that is a select line. So what I want is for the final function I want a plus b for the OR gate. So here it will be a complement, here it will be a. And now you need to know the property, that is I have already told you in the first lecture, that a plus a complement b is again a plus b. Since I have a complement, so I'll take a b here, and I want a, so I'll take a 1 here. So this particular function, if I take p as b, give me a moment. Yeah, so if I take p as b, q as 1, and then a r as a, so what will happen is f will be coming out to be a complement b plus a times 1, that is a plus a complement b, and that is getting reduced to a plus b, which is a OR gate. So this is how you can make any logic expression using this mux. So now let's do one more question, similar question. Let's do it a bit complex this time. So let's say I have a mux, a 4 cross 1 mux. I have I naught, I have I1, I2, I3. I have added these two to 1. This is 0 and this is 0. Let's say the select line are W and X here. The input of this going to another mux. It is I naught, I1, I2, I3. Here I2 and I3 are also 0, and this I naught and I1 are same. This is again a 4 cross 1, this is again a 4 cross 1. Here the select lines now are Y, Z, and this is a final F. So you need to compute F. So take maybe 2 minutes and let me know what is the expression that you are getting. I've got one answer is x w XOR x times y complement. So let's see. So here it is wx. So let me use some bit meaning. So it will be w 0 1. So it will be 1 0. It will be 0. So we can clearly see the ones are at I1 and I2. So by adding these, we will be getting a w XOR x. That is correct. Now I have both the inputs as w XOR x for this, and we can ignore this because it is a 0. So here I will be getting y complement z complement. Here I'll be getting y complement z. So if I try to compute f now, so it will be w XOR x times y complement z complement plus y complement z, and w XOR x, I can take y complement common. It will be z plus z complement, that will be 1. So finally it will be w XOR x times y complement only. So yeah, it is correct. So let's do the demux later. So quickly let me know the answer for this question. These are the two questions that we have already covered. So let me know the number here. You can take 1 minute maybe. This is very easy. You can either use the formula, you can use the technique of the initial division. Yes, 15. So let me use the division technique. So this will be 8, this will be 4, then this will be 2, and then finally it will be 1. So 8 plus 4 plus 2 plus 1 will give you 15 only. So we can write this as 2 raised to power of 4 minus 1, that is directly 15. Also quickly tell me in this answer now. You have now 4 cross 1 and you have now 5 and 2. So this is not basic 2 raised to power 2 cross 1. So we have a 4 cross 1. So quickly let me know what is the answer that you are getting. What one answer is 170. Anyone else? Maybe I'll give you 1 more minute. Let's let them try for 1 more minute and then I'll solve.
Sir, in this case, last reminder, what should it be?
So you have to always come up with a 1 only. If not, then uh, if the last remainder is greater than 2, then whatever the remainder is will be the last mux. Like, okay, so
Okay,
uh,
sir.
let me try to check this if the 1 is coming or not. So I have a 5 and 2. I have a 4 cross 1. So I'll start with 5 and 2 raised by 2. Will be 1 to 8. I'll go from 1 to 8. That will be 32. 32 by 4 will be 8. 8 by 4 will be 2. So here we are getting 2 and 2 by 4 is less than 1. So we are left with 2. So let's say this is half. So what I'll try to say here is we require 128 plus 32 plus 8 plus 2 plus half, that is here it is half, it's representing that at the last input we will be requiring a 2 cross 1 mux, because we only require two outputs of that. Instead of 4 by 4 I'm getting 2 by 4. So I need to have a 4 cross 1 mux in which two of them will be grounded. So for this, I need to add a 1 here so that I will have my final output. So if you add all of these, you will get the answer. So what is 28 plus 32 plus 8 plus 2 plus 1? This will be, I guess, 160, 168. So this will be 171. So option B will be correct. Is the doubt clear here?
So could you explain that half how becomes it one?
Okay, fine. So let me try to explain with an easier example. Let's say I have, let's say I have a 32 cross 1 mux. Sorry, I need to make 32 cross 1 mux using a 4 cross 1 mux. So what I'll do is I'll start with the 32. I'll get a 8. I'll then get a 2, and then I am left with 2 by 4. So let's say now since it is saying that I'll be requiring 8, so initially apply in the first what to say in the first state I'll apply 8 4 cross 1 muxes so that the total input will be 32, right? So these are 1 2 and this is 8. This will be giving me 8 inputs. Now I'll be requiring two more 8 cross 1, sorry, 4 cross 1 ones, because this will be giving me 8 inputs total. So I'm taking now two 4 cross 1 mux. So 4 will be connected here and 4 will be connected here. Is there any doubt till here? So if I take now two 4 cross 1 mux, this will only give me two outputs. So this final 2 by 4 is saying that I only have two left out of these 4. So I need to use either a 2 cross 1 mux, or if I am using a 4 cross 1 mux, I can only apply two inputs and rest I have to keep 0, or I need to give a select line as 0. So in this question, since the availability only depends upon this 4 cross 1 mux, so I need to add this last one to get this working of 2 cross 1 mux. I cannot ignore this half. Similarly, I cannot ignore this half because I need a 2 cross 1 mux. So for this, the answer will be something like 8 plus 2 plus 1, that is 11. Is it clear now? Okay, let's move. Yeah, so this might be interesting. So now you have to make, as I said, ki mux can be used to make any input or any universal or any gate. So now it is asking that how many 2 cross 1 mux are required to implement first this 2 input NAND, second is 2 input NOR, and third is XOR. The options are given. So maybe you can try it for 2 3 minutes and let me know whatever the answer that you are getting for each of the gates. So even if you get the answer for the first one, let me know that for NAND I'm getting this and this. So you can take 2 3 minutes and then I'll also solve simultaneously. Also try to do one thing, that only try to take, like if you are making NAND gate is this will be A dot B whole complement, so A complement plus B complement. So only use these inputs in the select lines. Just don't write the inputs. So we have done one example of XOR gate in which, sorry, XNOR I guess we did, in which what I did is I took this as one of the inputs. So don't do it. You can only use this inputs in the select lines. Both A and B should be in the select lines. Is it clear whatever I have said? The reason behind it is because we are not provided with the complement directly. In that case also, I guess I took one of the input as A B complement. So to get the complement out of some of the muxes, that is why I'm saying that you should only use it in the select line. Try it and let me know. Maybe it can take 5 minutes. Okay, so I've got the answer already. So rest of you also try. I one answer is C. Okay, so we'll see in maybe 1 or 2 minutes. Or some of them also. Please also give your answer. Anyone else with some answer? So let me try to solve. Since I've already given you idea for NAND, let me try for NOR and XOR first. So NOR is basically AB, and then we are getting A plus B whole complement, that is A complement dot B complement. As I said, you can only use A in the select line, and we have only 2 cross 1 mux, and we want the final expression to be A complement multiplied by B complement. So if I use this B here, and I am getting a B complement here, B here. So sorry. So what I have to do is I need to somehow extract A complement from here so that I can use these two things getting multiplied together. I can take this as ground or 0, so that these two getting multiplied together will give a f of A complement dot B complement, that is basically a NOR gate only. So for that what I'll do is I want a A complement, so I'll use 1 here and 0 here. This will give me final output of A complement, and I'll connect this here. So what will happen now, since B is of select line here, it will give me a f of A complement dot B complement, and that is final XOR, sorry, a NOR gate. So basically what we have done is we have made a NOR gate using a mux. So we can easily say that mux is a universal gate, right? You can say mux is a universal circuit. You can make any expression out of it. Similarly, there was, sorry, so for this case, I required two. Similarly, I guess one of them was XOR. So for XOR, again, I'll take A here and B here. Let's say I want, this is A complement, this is A. So what I want is I want both A and A complement here. So what I'll do is I'll take a 1 here, maybe a 0 here. This circuit will give me A complement here, and I want is A complement B plus AB complement. So what I'll do is I'll use this here, and since I have already have the select lines, I'll use this here. So what will happen is the final F will be A complement B plus A B complement, that is A XOR B. Do you understand this problem? So again I need two mux here. Is it clear to everyone? Any doubts here? Please respond if you don't have any doubts. Okay. So the answer will be for NAND also I will be requiring A complement plus B complement. So I'll take this A complement B complement, and I can take this A as one of the inputs. So I'll get again this thing, and this will give me A complement plus B complement. Similarly, this is A dot B whole complement. So I can use this theorem again. So for this answer will be C, that is 2 2 2. So since this is clear, so let's move ahead. So you need to compute X in this given circuit. So let me know it in 2 minutes maybe. Try to do it quickly because this is very easy. Okay, so one answer is A. Let's see for others also, and then I'll also solve it. So we've got two options. Okay, two of them are saying A. So let's try it out. So basically we have a A here and a B here and a B here and a C here. So I can write this as A complement B complement. This will be A complement B. This will be A B complement. This is A B. Similarly, this is B complement C complement. So I'll write it out. So from here I am getting 1 and 1 here, so we can ignore these things. So I can write this as, sorry. Okay, so this is basically XOR, so I'm directly writing this is A XOR B and A XOR B. So final X will be A XOR B times B complement C plus A XOR B times BC complement. Okay, so for sure it is not A because it is saying all of them are XOR. Let's try to calculate it. So A B complement plus A complement B is getting multiplied by B complement C, and similarly again C getting multiplied by B C complement. So this term will go away since we have a B and a B complement multiplication. So this term will go away from here, and here we have a B, so this term will go away. So if I try to simplify this will be A B complement C plus A complement B C complement. Is there any option? Is A complement A B complement C? We don't have this option. Uh, A complement B C complement. Yeah. Okay, so C is the option. Yeah, so option C is correct. So yeah, is it clear now? So those who are saying A, is it clear? Fine. So let's move ahead again. Okay, so try it out now. So it is saying that which of the following shows a correct representation of OR gate. So we have just done it. Maybe you can try it out and let me know what is the answer. So it is option A, B, C, D. Give it a go. Maybe it is very quick. So try to do it. Just so you solve each and every option. So let me know what are all these gates, like which one of them is OR gate, but some of them are also giving some expression. So if possible, let me know that what are these gates. First of all, try to compute the answer for this particular question, and then try to find out expression for all of the options and let me know what is A, what is B, what is C, and what is D. Anyone got any answer for OR gate? I take some time. Sorry. Still no answer. Is there any doubt? Are you getting any answer for OR gate? I'm asking. So let me try. Okay, so B is someone is getting B. This is A, so this will be A complement. This will be A. I am trying to solve each and every option. So this will be again A complement. This will be A. So here I am getting A times B. So here it will be AB, and then here it will be A. So for this option A, for option A, the final expression will be, sorry, final expression will be AB times A complement plus A. So this will be 0. I'm getting a. So option A is kind of a buffer because we are getting giving whatever input is some output as in the select line. So let's try option B, which is some of someone has calculated C also. So let's try. So I'll do it again. So this is A complement. This is B. This is okay. So whatever I'm getting from here will be select line for this. So let's see. So this will be 0 and this will be B. So B will be the select line here. So for second option F will be, so this will be B complement and this will be, sorry, I have not written it correctly. This is A complement and this is A. So I am getting AB as select line here. So this particular thing will be AB whole complement. This will be AB. So for second option, I'm getting the F as A B whole complement. That is A complement plus B complement. That is a NAND gate. So option B is not correct. Let's try for C also. I'm getting a complement and a here, a complement and a here. Since this is A complement B and this is 0, so 0 doesn't matter. So for option C, F will be A complement B plus, sorry, it is getting multiplied by A complement. So yeah, it will be similar only, plus this will be A. So this is nothing but A plus A complement B. That will give you A plus B. So yes, this is our gate. So option C will be correct for this particular question. And let's also calculate D since we have calculated each and everything. This will be B complement, this will be B, this will be, sorry, select line will be here. So I have a AB complement and a 0 here. So AB complement and I will be getting AB complement whole complement and here it will be AB complement. So final F for last option will be AB complement whole complement, that is A complement plus B. So this is not any gate, this is just expression. So for the above question, the correct answer is option C. Is there any doubt?
Explain option B, sir. That
Option B.
yeah, sir.
Okay.
The second input select line is A
Yes, yes.
AB, right?
So here you can see this is A complement, this is A, and since we have a 0, so I'm not bothered about this. So AB will be the output of the first multiplexer and AB will be the select line now. Let's say AB is equals to P, right? So the here it will be P bar and here it will be P. And again, I'm not bothered about P, so the final F will be P complement. P is nothing but AB whole complement. So this will give me a complement plus P complement, or this also is a NAND gate. Still any doubt? Okay.
Not present.
Okay. So now we have this is also so now the question has what has done is it is given in the terms of min term, and now you need to make it using a 8 cross 1 multiplexer. So 8 cross 1 means 2 raised by 3 cross 1 means 3 select lines. This is a very easy question. So let's try. So we have 1, 2, 3, 4, 5, 6, 7, 8. We will have 3 select lines and we will have a final F. I'm taking it A, B, C, D. So let's say I'm taking A, B, C as select lines. So you need to give me all of the values like, sorry, this will be I0, I1, I2. Need to compute all these values, which will be basically a function of D. As we all know that only D is left. So quickly let me know these values. This is very easy. So maybe you can take 2-3 minutes and let me know what is the answer that you're getting. So let's give it a go. We already know the min terms. So what I'll do is I'll write the min terms directly. This will be 0 will be all the bars, and 1 will be 0, 0, 0, 1, and 5 will be 0, 1, 0, 1, 6 will be 0, 1, 1, 0, and 8 will be 1, 0, 0, and then finally 0. What is left? 10. 10 is 1, 0, 1, 0. 12 is 1, 1, 0, 0, and 15 is basically everything. So let me write also. So this is 0, 1, 2, sorry, 5, 6, this is 8, 10, this is 12, and this is 15. And we already know that we have this A, B, C, A, B, sorry, what will be this? 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 0, and finally ABC. So you can see for A bar, B bar, C bar, we have these two terms. I guess only these two are there. Yes, and one has a D complement and one has a D. So if I take both of them as common, so it will be D plus D complement. So this is basically 1. So in this node, I want a 1. So these two are covered, so I'm just crossing them. Now for, let's say I'm taking 0, 0, 1, is there any term? A A bar, B bar, and C there is no term as such, so I'm taking this as 0. Now the next term is this A bar, B, C bar. Again there is a single term, so I can have a D here. So this is a D. I'm crossing this term. I have A complement BC, and I have A complement BC again. No. So I can have a D complement here. Now I have A B complement C complement, and yeah, only once I have it, so I can have a D complement here. Then I have this A B complement C, and I have a D bar here. Similarly, ABC complement also has a D bar, and finally ABC also has a D. So did you understand how I've made it? Is there any doubt? Please let me know if there is any doubt. Has everyone understood? Please respond if it is clear. Let me try to give you similar question. So let's say question is you need to find P and Q if XYZ is a majority function. I hope you remember I did told you what is majority function or a majority gate function. There can be two names. So you need to remember it first of all. What is it? And then you need to calculate. So let's say I make a circuit. This is YZ. So dot means it is connected. So let's say this is something a block P. Again YZ. Let's say this is a block Q. And then I'm giving it to a mux which has a select line X, X, Y, Z. So all of them are covered now. So this is sorry, this is a 2 cross 1 mux, and this is final F. So F X Y Z should be a majority function. For that you need to calculate Z and Y. First of all, let me know, is the question clear? Is there any confusion here? Then only I'll give you time to solve this. Is the question clear here? You need to calculate P as a function of YZ and Q as a function of YZ basically to make it a majority function. Is the question clear? Say yes or no. Please let me know if the question is clear. Otherwise, there is no point of giving you time to solve it. Should I explain again the question? Okay. So what I'm trying to say is you need to compute this P and Q in terms of Y and Z. You can use Y, Z as inputs if this is confusing. So let's say you can make this circuit. You can write directly PQ. You can take X as select line, and this is F, which is X, Y, Z. You need to make compute PQ in terms of Y, Z, so that this is a majority function. Is it clear now? Okay, fine. So let me know what is P and Q that you are getting. You can take 2-3 minutes now. Okay, please give another example. What example are you talking about? Like a similar question to this? Okay. So have you solved this already? I'll give you one more. Uh, so okay, let me try to solve this, and maybe you can take one more example. So we already know. So it is a majority function, a three input majority function. So this is nothing but, if you remember, it is 3567. I hope you already remember this. So 3567 in terms of x, y, z will be 3 will be 0, 1, 1, 5 will be 101, then 6 will be 110, and basically 7 will be x, y, z. So I have a x complement here, I have a x here. So if I talk in terms of x complement, then I need y, z. This is the only thing that I can take to make this work for x complement. And if I talk in terms of x, if I take this common x, I need a y, z, y complement, then y, z complement, and finally y, z. So what I'll do is I'll take y common from last two terms. So yz plus z complement. This will give me y complement z plus y, or I can write this as y plus z, because y plus y complement z will be y plus z. So I can write q as y plus z. So basically p is a AND gate of yz and q is a OR gate of yz. Is there any doubt in this? Okay, so if you have understood, maybe let's not go that much. So do it again if it is a XOR gate now. You can take 2 minutes now. Try to do it quickly. Now I have a XOR gate. Let me know what are P and Q. Any answer? Yes, so I'll do it then quickly. XOR gate is 1247. I already told you. So one is 001, who is 010, 4 is 100, 7 is 111. So for X bar, you can see uh, it is y z, y bar z plus y z bar. So P will be y XOR z. Similarly for Q it will be I guess for Q it will be y z plus y z. So it will be X XNOR. Does it make sense? Is it clear? Is it clear, or I should give more examples? So this is for XOR, and this is for majority gate. Is it fine? Should I proceed? Okay, so try this now. Again, we have two multiplexers. We need to compute the final F. Now try to take 1 or 2 minutes only because this is very easy. Okay, so let's see. I've got one answer as B. This will be x complement, this will be x. So here it will be x complement y. Here it will be the knot of that. So I'm just writing x plus y complement. Here it will be z bar. Here it will be z. So final F will be x complement y z complement plus x plus y complement times z. So let me just open it. So it will be xz plus y's complement z. So is it B? Yeah. So option B is correct. I hope it is clear. It was very easy. So I'm just moving ahead. Yeah, so this is a good question. So what you need to do here is you need to compute. So we have a 4 cross 1 mux first of all, in which I have always I naught, I1, I2, I3. We have a function which is a 4 variable function, and we only have a 4 cross 1 mux. That means 2 select lines, right? And it is given that you need to check only take A and B as select lines. So each of them is a function of C and D now. So you need to compute I1, I naught, I1, I2, and I3 in terms of C and D. That is also given in the options, so that the final F, sorry, will be this 0, 1, 3, 4, 6, 8, 10, 11, 12, 13, 15. So try to do it quickly. Maybe you can take 3-4 minutes to solve it and let me know what is the correct answer. Have you understood the question? Is question clear, everyone? Fine, I'm assuming it is clear. So take 3-4 minutes and let me know what is the answer. Any answer? Anyone even have, if they've calculated any of the term I naught or I1? Okay, so let me try to do it. We know that since we have a 2 cross 1 mux, so we have these four combinations here. We need to calculate I naught and we already know what is the F. So I'll write F here. F is 0, 1, 3, 4, 6, 8, 10, 11, then 12, 13, then 15. So I'm just writing one by one quickly. Writing 0 is, since we have a 4 variable now, we will have a 1, we will have a 3, 3 0 1 1, sorry, 0 1 1, then, oh, I've written it wrong, 0 0 0 1 1, then I have 4, that is 0 1 0 0, then I have 6, which is 0 1 1 0, then 8 is 1 0 0 0, 10 is 0, 11 is 8 2 and 1. So 11 is 8 2 and 1, so this will be 1 0 1 1, yes. Value is 1 1 0 0. 13 is 1 1 0 1, and finally we have 50. I hope I have written everything correct. If I have written something wrong, do correct me. We have a complement, B complement. Sorry. So for the first input, we have a complement, B complement. So we need to first of all take all the terms common which have this A complement, B complement. This is one, this is one, and this is one. Rest of them does not have it. So for I naught, we will have A complement, B complement in common with C, D complement, C complement D, and then C, D. So let's try to solve only this part. So taking C complement common, it will have D plus D complement and then CD. It will be 1. So C complement plus CD, and this is nothing but C complement plus D. So I naught in terms of C and D will be C complement plus D. Okay, so there are two options in which, so either A is wrong, oh sorry, correct, or C is correct. So we need to calculate only I1 now. If we calculate I1 as D or D complement, we can say for sure that which one is correct. So for I1, we have terms for A bar B. So A bar B is this. Let me use different things. So one is this, one is this. Yes, only two terms are there. So if I try to calculate I1 now, I am taking A bar B common, so it will be C complement D complement plus C D complement. So if I try to calculate here, I can take D complement common, so it will be C plus C complement. That will be 1. So I1 will be D complement. So yeah, we can say for sure that option A is correct. We don't even need to calculate I2 and I3. They will come out to be these only. If you want to if you want to calculate this, you can calculate this as a homework problem. But I guess it is fine to say that this is how you do it. Is it clear to everyone? Any doubts? Is it clear? Fine. So let's move ahead now. So this is again a good question. Now the question is, what should be the value of D naught to D7? So you can see there are certain inputs here. It is D naught to D7, and there are several combinations here. So that the output F, so this is a vertical circuit, follows the sum of inputs. So follows the sum is one of the terminology which means XOR. So basically follows the sum of A, B, C means A XOR B XOR C. So you need to get this as A XOR B XOR C using any of these combination. So the thing here is there is no shortcut. You need to check one by one that which combination is giving you the final output. So this might take time. So just for clarity, you can take option A as the first choice and let me know what is the F that you are getting. If this, let's say this is 0, 1, 1, 0, 1, 0, 0, 1. So if I give you this as the input, so let me know what is the F. You can take 5 minutes now and quickly let me know whenever you will get some answer. Any answers? Okay, so let me try to calculate also simultaneously. This will be C complement, this will be C. Similarly, it is the case for everyone since C is a select line. So here it is 1, so this will have a C. Here it is 1, so this will have a C complement. Here we have C, and here we will have a C again. Yes. So I'm calculating this block now. So I have a B.
B for C complement, sir.
Sorry, okay, I've written something wrong.
Yes, sir.
Which part? Okay, yeah, I get it. This will be C complement. And so what I was writing, yeah, so it will be here now. So now the input here will be B complement C plus BC complement, and here it will be B complement C complement plus BC. Final A will be now A complement multiplied by this thing and A multiplied by this thing. So I'm doing it here only so that it looks fine. So A complement is B complement C plus BC complement plus A is B complement C complement plus BC. So I'm just opening it so that it is easier to look. What is this? So this is A complement B C complement, then A B C complement, and then A B C. So if you see in terms of min term, since you remember, you need to calculate XOR gate, so you should have a 1 2 4 7 relation in terms of min term. So let's see, this is 0 0 1, so it is 1, it is 0 1 0, so 2 4 7. Basically, this is 1 2 4 7, so this is the XOR combination for A XOR B XOR C. So option A is already correct. Similarly, you can check for all the other options also. Maybe in the next class, you can let me know what is the output expression coming for, maybe in terms of min term only for all of these options. Is this question clear? Solution, is it clear? Okay, fine. So let's move ahead. So let's move this. This is theoretical. Similarly, we have solved a lot of questions for mux. So a similar concept apply for demux or decoders. So there are two things. One is encoder, decoder. So for mux, we are doing that for a 4 cross 1 mux. How many 2 cross 1 are required? So we do it for 2 plus 1, that is 3. Similarly, for decoder or demux, what we do is in decoder we have a single input, but in sorry in demux we have a single input, but in decoder we can have multiple inputs. So we will see. It says that for how many 3 cross 8 decoders are needed to construct a 6 cross 64 line decoder. So basically you have to do the same thing, just take the higher values and do the same thing as you were doing for mux. So this is 8, sorry, so this will be 8 plus 1, that is 9. I hope this is clear. This is easy part now. So I'm just letting you know how to solve this similar problems for decoders or demux also. So in mux we have 2 raised power n cross 1. In demux we have 1 raised power 1 cross 2 cross n. In encoder we have n 2 raised n. And in decoder we have 2 raised power n cross n. Is it clear, this particular table? This is the input output basically. Is it clear? Please respond if this is clear. Fine. So quickly let me know the answer to this. So you need to implement this and you need to check what options are, which option is correct. Take 2 minutes and let me know the answer. Any answers? So we have 5, 5 by 32. So Let's try it with the larger option first, that is 8. So let's say we have 3 cross 8, so I'm doing 32 by 8, so this will be 4. This is half, so it will be 4 plus something, so this is not correct. 2 is obviously not correct, we need more. 8 2 cross 4, so let's try for 2 cross 4 also. 32 by 4, that is 8, by 4, that is 2, so it will not be 8. So let's try with the first option. We have 4 3 cross 8. Yeah, so this is the option that was already have calculated. So 4 3 cross 8 plus half, so half is 8, we need to have a 4. So 1 2 cross 4 decoder and 4 3 cross 8 decoder, so option A is correct. I hope this is clear, this is very easy. I'm proceeding ahead. So in the following circuit, X is given by, so I'm also doing the same, and you should also try to do it simultaneously and let me know the answer if possible quickly. So we have 1 1 here, so this is A XOR B, we have already seen this. So A XOR B is now one of the select lines to this, so we need to compute this X. So what I'll do is, first is A XOR B complement times C plus, second is A XOR B times C complement. So it is basically XNOR first expression, and then this is XOR. Now opening it up to get to know the four terms. So ABC is 1, ABC is second, and A complement B, C complement. So let's try to see which is this. ABC is here, and then we have this also, AB, yeah, this also, and yeah, so option A is correct. Is it fine? I'm moving quite fast now because we are running out of time. Is it fine? Please respond quickly. Should I explain again or is it fine? So similarly, okay. So now this is a twist in the question that you need to calculate this in the POS form. We have generally seen that all the answers are given in the SOP form because of the nature of this mux. So now what we'll do is we'll calculate the min terms only, and then the dual of that will be max terms. That is, whatever min terms we'll have, we'll write rest of the terms in the terms of max terms. To do it quickly, so this is A complement. Sorry, I can write this as, and this is 1 0. So I'm just writing it quickly. You should also try to do it quickly. First term will be A B complement C complement. Second term will be A complement B complement C. Third term will be B C complement. Fourth term will be 0. So just to make it standard, I'm writing A plus A complement B C complement will be A B C complement plus A bar B C complement. So this will be 0 1 1, that is, sorry, 1 0 0. So this is 4. This is 0 0 1. This is 1. This is 1 1 0. So this is 6, and this is 0 1 0. So this is 2. So I'm getting the main terms as 1 2 4 6. So I can write easily in the terms of max term, this is 0 3 5 7. So the answer here will be max term 0 3 5 7. Is it clear? Is it clear, everyone? Fine. So now again we have a similar mux question, that determine the inputs of 4 cross 1 mux, that is D3 D2. Now you need to see that D naught is given at the lowest part, so this will be the complement part now. Sometimes they give it in this way, that D naught is in the lowest input and D3 is in the highest input. So determine the inputs to make Q as X, Y plus Z. X is the MSB, X is the MSB, and Z is the LSB. Okay. You can select X, Y as a select line and Z as the input. So X is the MSB, right? Yeah. So I'll write now here X Y bar, X bar Y, X Y complement, and X Y. It is opposite because of the given question. Now we need to calculate Z as the input variable. So we need to calculate all of these things to make q as x, y plus z. So what I can do is I can maybe try to find out the min term, or I already have this x, y here. So in x, y we want a 1 and I have a z remaining. So what we can say is for all the terms that is giving me a 1, I need to have a z, and for this first term I need to have a 1. So I can even try even solve it directly, but for the sake of clarity let's try to do it one by one. So for xy, sorry, you can clearly see for xy we need to multiply it by 1. So for d3 is for sure that it is 1, and for rest of the terms we need to cancel these terms so that we are only getting a z. So basically what we will do is we will give input to z here. What it will do is, since we have given 1 and a z here, so the rest terms are x bar y bar plus x bar y plus x y bar. This will be x y plus z. So I'm taking here x bar common, will give me a 1 plus x y bar, and I'm taking z x bar plus y bar will be the term. So I can write this as, sorry, xy plus x bar z plus y bar z. Can I take anything common? Okay, so this is not the correct combination, I guess. I need to check it again. I want this as 1 also. So what other combination is given? 1 z z z, 1 1 1 z. So let's try this 1 1 1 1 z. If this is 1 and this is 1 and this is only z, what will happen is we will have x bar common, x bar common. So x bar is the only thing that is left. So x plus x bar y plus x y bar z, x, sorry, this will be x y, x plus x y bar z, so x will be common. Okay, so this is not possible. Sorry. I think it ran. Sorry for the glitch. I'll rewrite the answer for this again. I guess it was 246. So it was 0357. There was some internet glitch. It went away. So we need to make sure that D3 is 1 so that we will get a XY cleanly. So answer is either A or B. Maybe since we are running out of time, you can check the options. If you will not get the answer, then we will discuss this particular question in the next lecture also. I'm like leaving this for now. So again, I have some similar questions. We have a y which is 1 2 3. Sorry, we need to identify the output. So this is c complement, then 1. So again, I'm writing it quickly. Y will be a bar b bar c plus a bar b c bar, and then last will be a b complement. This will be, sorry, this will be c plus c complement. So this will be 0 0 1. This will be 1 0 1, that is 0 1, that is 2, 1 0 1, that is 5, that is 4. So 1 2 4 5, option B is correct. You can also check similarly. I'm doing it quickly because of the lack of time. I hope this is clear. This might take time. Maybe you can take a photograph of it and take it as a homework problem. Let me know if you have already taken quickly. Have you taken? Fine. Okay, similarly, you can take the photograph of this also. You need to find the Boolean expression, all the inputs are given and all the select lines are given. Have you taken it? Okay, so let me try to solve this quickly. Maybe we have 2-3 minutes. So we have a ground here. We need to calculate the final output. So we will have a 1 here, ground here, 1 1, and then 0. So again it will be XOR. We have done a lot of questions, so this will be XOR. So option D will be correct. You can check it also. So output of the circuit shown in the figure is, so we have a 1 here. So we will have a 1 1. So 0 times, yeah, 1 here, and then we have a 0 here. So here we have a 1 0. So here we will have a x. Since we have a 1, so we'll have a 0 1. Put as x. Is this question, have you understand this? Since we have a select line as 1, so we need to take 1 bar here and 1 here. So that is why I have written 0 1. And then 0 times 0 plus 1 times 1 will give you a 1. Now I have a 0 here. So I need to write 1 here and 0 here, because this is 0 complement and 0. So x times 1 plus 1 times 0 will give you a x. I have a and x here, and I have a 1 here, so I need to write 1 complement here and 0 here. That's why I have written 0 and 1. Sorry, this is not 0, this is 1. So a times 0, sorry, output is a times 0 plus x times 1. So that is why it is x. So option B is correct. Okay, this question is repeated, so you can ignore this. So do you have any doubts as of now? Maybe you can take these two as homework problems. I'll also share this PDF also. So you can take a look from that and let me know the answer in the next class. Is there any doubt, anyone? Fine, then we can dismiss today's lecture and we'll meet in the next week at the same time.